Have you ever just looked around and wondered how all of this works? From a tiny falling raindrop to a massive, swirling galaxy. How can we possibly describe all of that with just a handful of rules? Well, that's the absolute magic of physics. Think of it as the instruction manual for the universe. And today, we're going to take a peek at the source code of reality itself.
So this is the big question, right? This is what we're here to figure out. How is it even possible that a few core ideas can explain all the crazy complexity we see every single day? To get to the bottom of it, we've got to start at the very beginning.
And to do that, we're going to take a little 5-step journey. First, we have to learn the language, the words physicists actually use. Then we'll use those words to tell the story of motion. After that, we'll dig into what causes things to change in the first place, look at the universe's universal currency, which is energy, and finally, we'll get to the ultimate unbreakable rules of the entire game.
Look, every subject has its own jargon, its own language, right? And physics is no different. So before we can understand its most powerful laws, we need to get a handle on its most basic vocabulary.
Okay, so scalar versus vector. This might seem a little picky, but the difference is absolutely crucial. A scalar just tells you how much, like your car's speed is 60 miles per hour. But a vector tells you how much and which way. Your car's velocity is 60 miles per hour north. One tells you a number, the other tells you where you're actually going. It's a huge difference.
And to measure any of this stuff, scientists all over the world needed to agree on a standard. That's where these 7 base units come in. They are the absolute bedrock. The cool part? From just these 7, we can build every other unit we could possibly need to describe the physical world.
This is such a great way to think about it. You know how an artist can mix red, yellow, and blue to get any color imaginable? Well, a physicist can combine these 7 base units, like meters, kilograms, and seconds, to create the exact unit they need for anything, whether it's for force or for pressure or anything else. And see how beautifully this works? The system is so logical. The formula itself literally tells you what the units have to be. We all know velocity is just distance divided by time, so the units have to be meters divided by seconds. Simple as that. This clean logic is what makes physics so powerful.
All right, now that we have our vocabulary down, we can start to write the first sentence in our story of the universe. And that sentence is all about describing how something moves from point A to point B. So think about it like this. It's a chain of events. First, you have displacement. That's just your change in position and in which direction. Then you have velocity, which is simply how fast your displacement is changing. And finally, you've got acceleration, which is how fast your velocity is changing. See the pattern? Each step describes the rate of change of the one before it.
And here is the truly incredible part. With just those 3 ideas, displacement, velocity, and acceleration, we have everything we need. We can completely describe and predict the path of a thrown baseball, a speeding car, or even a planet orbiting the sun. It's an incredibly powerful toolkit.
Okay, so we're getting pretty good at describing motion, but that leads us to a much deeper question. What actually causes motion to change? What makes something start moving, or stop, or turn a corner?
The answer, in one word, is force. You can think of forces as the verbs of physics. They're the pushes and the pulls that make things happen. If there's no force acting on an object, its motion will simply never, ever change. It'll just keep on doing what it's doing. And this is where the great Isaac Newton comes in. His first law, the law of inertia, is basically the do-nothing law. It says an object at rest will stay at rest, and an object in motion will stay in that same motion forever, unless something messes with it. And that something is what his second law is all about. This law is the recipe. It's the famous F equals ma. It gives us the exact mathematical connection between how much you push something, the force, and how much its motion changes, the acceleration. It's beautifully simple.
And his third law is, well, it's pretty profound. It basically says that in the universe, there are no solo acts. Every single force is an interaction. For every action, there is an equal and opposite reaction. You push on a wall, and that wall is pushing back on you with the exact same force, always.
So, forces cause changes in motion. We've got that. But whenever a force does something, like lifting a heavy box off the floor, there's a kind of transaction that takes place. A universal currency gets exchanged. And that currency, my friends, is energy.
Now in physics, the term work has a very specific meaning. It isn't about how tired you feel. It's a precise measurement of energy being transferred. It's calculated as the force you apply multiplied by the distance the object moves in that direction. And here's the kicker. If you push on a wall with all your might but the wall doesn't move, you've done zero work.
This energy really comes in two main flavors. You've got potential energy, which is stored energy. It's the energy of what if. Think of a stretched rubber band or an apple hanging in a tree. Then you have kinetic energy. That's the energy of motion, the energy of what is. It's the rubber band flying through the air or the apple as it falls. And really almost everything that happens is just energy converting from one form to the other.
Okay, this brings us to the top of the pyramid, our final section. We're about to look at the most fundamental, the most profound, the most unbreakable rules in all of physics. These are the conservation laws. And as far as we have ever been able to tell, these laws are never, ever broken.
First up is the law of conservation of momentum. Now, momentum is basically just an object's mass multiplied by its velocity. It's mass in motion. What this law says is that in any closed system, like two billiard balls colliding, the total amount of momentum before the collision is exactly the same as the total amount of momentum after. It doesn't disappear, it just gets passed around.
And that brings us to the big one, the law of conservation of energy. This might be the single most important rule in all of science. It's the ultimate accounting principle for the universe. It means the total amount of energy that exists is fixed. It's constant. You can't make more, you can't destroy what's there. All you can ever do is change it from one form to another.
And so, that leaves us with a pretty mind-bending question to chew on. If the entire universe is a closed system, and the total amount of energy and momentum inside it is forever fixed, what does that really mean? It suggests that everything we see, every star being born, every decision you make, is all just part of one grand cosmic reshuffling of stuff that was already there. The total never changes. And that is a truly powerful idea.